Number 32, it says a person driving her car at 45 kilometers per hour approached the intersection just as the traffic light turns yellow. She knows that the yellow light lasts only 2 seconds before turning red. And she is 28 meters away from the near side of the intersection. Should she try to stop or should she speed up to cross the intersection before the light turns red? The intersection is 15 meters wide. Her car's maximum deceleration is negative 5.8 meters per second squared, whereas it can accelerate it from 45 to 65 kilometers per hour in 6 seconds. Ignore the length of her car and her reaction time. So let's just do this in 2 parts. Let's do a stop part and a go part. All right, and let's write down the information for each part. So her initial velocity is 45 kilometers per hour. So V sub 0 is 45 kilometers per hour, which needs to be converted to meters per second. How much is that? Anybody have it?
12.5 meters.
Okay, so 12.5 meters per second. If she stops, her final velocity is going to be 0. The acceleration is her deceleration is negative 5.8 meters per second squared. And the distance that she has to stop is 28 meters. So I'm going to say x of 0 is 0. X is 28 meters. And it really doesn't matter what the time is, because as long as she stops before she gets there, that's irrelevant. Maybe what we ought to do is let's make this x value a question mark and see if we can get it in less than 28 meters. That would probably be the easiest way to do it. And so let's solve this first. I would just use a b squared equation. B squared is equal to v sub 0 squared plus 2ax, or 0 is equal to 12.5 squared plus 2 times negative 5.8 times x. And let's see how fast she can stop. So 12.5 squared divided by 2. Try again. And you get 13.5 meters. So this is obviously less than, what was it, 28? 28 meters. So she can stop. But let's go through and see if she can go also, which is always a possibility. The first thing we need to find, they give you the information for the acceleration, and why do that. So we can say A is equal to question mark, or we'll just say A is equal to, I'm going to write the equation like this. V is equal to V sub 0 plus AT. And it tells you that the car can accelerate from 45 to 65 kilometers per hour in 6 seconds. So time is 6 seconds. Initial velocity is 45 kilometers per hour. Final velocity is 65 kilometers per hour. So what do you get for, if you convert those to meters per second? Does somebody have them? See, this is 12.5. We've got that one already. What's 65 in meters per second?
18.1.
Okay, so 18.1 meters per second. So let's plug the numbers in. I'm going to write them over here. 18.1 is equal to 12.5 plus A times 6. If you solve for A, anybody have that one?
Oh, 3.33 meters per second squared.
Okay.
Acceleration?
Yeah,
Oh, maybe I did something wrong.
I've got 0.93.
Yeah, I probably did something wrong there.
Does that, anybody else have it?
Yep, that's what I have.
Okay, so 0.93 meters per second squared. So that's our A value. Her initial velocity is 45, which is 12.5 meters per second. What's the time? How long does she have to get through there?
2 seconds.
2 seconds. I don't even know if we need to. Maybe we ought to solve for the time. What's the distance all the way through the intersection?
43.
Okay, so X is 43 meters. And so we can solve this a couple of ways. You can use this equation. X is equal to x sub 0 plus v sub 0 t plus 1/2 at squared. And you're going to get 2 times. You're going to get a negative time and a positive time, I think.
Yeah.
But you've got to solve the quadratic. Okay, and that's fine if you want to solve it that way. All right, and the quadratic equation is in the back of the textbook if you don't have it memorized. But let me show you a different way to do it. Okay, so this is going to take 2 steps, but if we solve for, I'm gonna solve for the velocity at the end of 43 meters if we have this acceleration. So I can use a v squared equation. We can say v squared is equal to v sub 0 squared plus 2ax. So v squared is equal to 12.5 squared plus 2 times 0.93, that's a 3, times 43. And this is going to give us our velocity there at the end of 43 meters. So let me see what that ends up being. So this is about 80. And then 12.5 squared is 156. So 156 plus 80 is 263.25. We'll take the square root of that. You get 15.3, 15.4 meters per second. So that's how fast we're going at the end of the intersection. All right, then we can plug it back into this equation, and we can say v is equal to v sub 0 plus at. We can say 15.4 is equal to, what was the initial velocity? 12.5 plus 0.93 times t, and we can solve for t. It says that she's got 2 seconds to get through the intersection. And if this is not 2 seconds, it's going to take too long, and she should stop. So 15.4 minus 5 divided by 0.93 is 3.1 seconds. So that's going to take too long to get through there. And so what should she do? She should stop. Okay? So if you solve the quadratic, you should have gotten 3.1 seconds also. And there's probably more ways to do it too. Zach?
How did you get the acceleration at 0.93 meters per second?
We forgot to change it from kilometers an hour to meters per second before. I think we got the same answer, so I got 3.32.
But it should be the same, shouldn't it?
You got, if you leave it in kilometers per hour, your units are going to be kilometers per hour per second. Which is fine, but that messes up all the rest of your units too.
Teachers, sorry for the interruption. At this time, any freshmen and sophomore football players